All right. So we're looking at this lesson. It failed to record in class, so I'm doing a quick lesson. And um, basically, what we're doing here is we're looking at correlation coefficients. So the main thing with this is, we've been talking about lines of best fit, lines of best fit. And when we're doing a correlation coefficient problem, we're talking about the line of best fit as well. But we're in like thinking about residuals, how far off of the line of best fit it is, the correlation coefficient's related to that as well. Now, what we have to do today is pretty easy to accomplish because we're going to use a calculator technology to work some of this out. But we need to know a little bit more about what it is. So the correlation coefficient we see as our letter R, and it tells us how well the data matches a linear function. How close to being in a line it is. A line going up where it's positive, a line going down where it's negative, or a weak correlation where there's really nothing that you can make. You can't tell if the line goes this way, up, down. It doesn't, you can't tell. Okay. Now the R value is going to be between -1 and +1. That's the entire range from -1 to +1. So -1 means it's a straight line and it goes straight down. +1 is a straight line and goes straight up. And 0, as I mentioned, is kind of like you can't make a correlation, right? A correlation is just a relationship between two values. So if this was talking about, if we were talking about days and money, right? Maybe these are days that you're tutoring, and you start out Monday, you get paid this much money, you get paid like $20, and then the next day, Tuesday, you get paid 20 and 18. Wednesday 18, Thursday 18, Friday, 15, 15. And then by Saturday, you're only paid like $5. So a negative correlation means that in relation to the days of the week, your money that you earn is going down. So this is like if you weren't that good of a tutor. Again, if this was days and money, this might be just randomness, right? So different days of the week, you're just paid different values by different clients you have for tutoring. This, as we go through the days of the week, you're getting paid more as you go through the week. By Saturday, you're paid like $100 an hour. You're the most expensive tutor of all time. So this is a positive correlation because it's saying in relation to the days of the week, right? You're getting paid more every single day. Okay. Compared to the days of the week, your money is random. There's no correlation we can make. There's no relationship we can make. So the first part of figuring out the R value, the correlation coefficient, is to make a scatter plot and look at it, figure out if it's a negative, a weak, or a positive correlation. And there can be a weak positive correlation where it's in the middle. There can be a weak negative correlation where it's in the middle. It's not all one straight line. So you just use those words to explain it, okay? Now to find the R value, we have to plug the data values into a correlation coefficient calculator. And that's what I have on the screen as well. Then you can assess the strength of the linear relationship, okay? So in example 1, we're talking about how many books you read and the relationship, the correlation between books you read and your test score, okay? Between the books you read and your test score. You can see we have a bunch of different values. This is saying, hey, if you read more books, are you going to get a better test score? If you read less books, do you get a worse test score? And so on. So the first step, and for the homework as well, is going to be create a scatter plot. Now, be careful when you do this. Be careful when you do this, because the scatter plot, you have to look at the range of values that you're looking at. Okay, so the range of values that we're looking at here, let's see, X and Y, books read, we go from 8 to 19. So you see I set it up where I go all the way out to 20. And then for the test scores, we go from 3 to 56. So I counted by fives, and I got all the way to 60, and that'll cover everything. So I make all these points that are based on my data, right? And then the second question is describe the relationship. What is the relationship? Is this a positive, a negative, or a weak relationship? I mean, where would you make your line? You can make your line here. You can make your line there. Someone can make it there. There could be all these different options. So when we did this during the lesson, we decided this is a weak relationship. I don't know my R value, but I know it doesn't really go in a line. It doesn't go in a line. So I'm going to say that it's a weak relationship. Okay. So that is the second part of what you have to do. Create a scatter plot, describe the relationship. Now we got to find our R value. So we're going to go over to the calculation, our correlation calculator, and we need to add some more rows. We need to have 7 rows, 4, 5, 6, 7. And what I'm going to just input are our values. So we have 12, 23. So use the tab key to move between the fields. And this goes pretty quick, actually. 9, 8. We have 14, 56. We have 19, 19. We have 6 and 40. You see, that one's so hard. You calculate, and it's going to give you the correlation coefficient right there. Oh, that's nice. So what we just figured out was, for this data plot, scatter plot, from this data over here, we end up with an R factor. Because it was negative 0.0049, I rounded that to 0.005. The reason why it's fine to round in this respect for this problem is it's so close to 0. It's so close to 0, right? It's like, here's 0, here's negative 1 to 1, and it's right there, just barely negative. So what this is saying is, like, here's our correlation coefficient, barely, negative, barely negative, but it's so close to the middle that we can say it is definitely a weak correlation. Okay, our R value is so close to 0 that we're going to call it a weak correlation. Okay, weak correlation. And the R value, I mean, because it's close to 0, that's one reason why it's also weak. But we also just looked at the relationship of books to score. And so this is stating that it doesn't really matter. It doesn't really matter how many books you read based as far as output of your score. So that is my math input to just stop reading. No one needs to read anymore. You're probably fine if you don't really like to read. Just kidding. Reading's fun sometimes. All right. Okay. Well, that concludes the lesson for today. And thank you for watching. And I'm going to try to see if it'll allow me to stop it now. Let's see. Let's think about it. All right.